plus 6x minus 5. Write in descending powers, then take minus 1 common, so that the coefficient of x square is plus 1. Then what is the coefficient of x? It is 6. Make half of it, add square, then subtract square. As a result, we have a perfect square. And then plus 9 minus 5. So this is our required perfect square. 4 minus x minus 3 whole square. Hello class. Today we are going to start new series of past papers of A-level mathematics 9709. We are going to start from session 2016 May-June paper 1 of A-level mathematics. All the questions will be solved in detail so that there is no doubt and ambiguity. G, and we are given with the condition that f of x equals to g f of x, g f of 2. So let's solve these two sides, left hand side and right hand side, and after that we will equate these two sides. Let's start with the left hand side. In the left hand side we have f of x equals to f of 10 minus 3x. So replace x with 10 minus 3x in the function f and then simplify. So we have 10 minus 30 plus 9x. So finally we have minus 20 plus 9x. This is our left hand side, which is f of x. Let's say this is equation number 1. Now let's solve equation right hand side, which is f of 2. F of 2 is replace x with 2, 10 minus 3 to the 6, which is 4. Then g f of 2, which means g f of 2 is 4. Then replace x with 4 in function g. So we have 3 minus 4 to the 8, 10 over minus 5 minus 2. This is our right hand side. Now we have two sides, left hand side, right hand side. Let's substitute the values. So we have minus 20 plus 9x equals to minus 2. And let's simplify this equation with the negative sign. So x equals to minus 2. Question number 2. In question number 2, we are given with the first derivative of the curve dy over dx. It is also given that this curve whose derivative is given passes through the point 2, 7. Find the equation of the curve. We know that whenever we have a first derivative, it is obtained from the curve by taking its differentiation. So if we want to go back, we are supposed to do the reverse of differentiation, which is integration. So what we are going to do, we will integrate left hand side and the right hand side with respect to x. So by definition, this left hand side will become y, and we will integrate the right hand side. We know the method. We will increase the power by minus 1 and divide by minus 1 into 1 over the derivative of 5 minus 2x is minus 2 and plus c. Now simplify this. Y equals to 2 1s are 2 4s are 4 minus minus plus, so 5 minus 2x plus c. This is our general solution. If we are not given with any point on the curve, then that would be our final answer. But in this question we have point 27, which is on the curve. So let's replace that point in the general solution. Y is 7 and x is 2. 2 2s are 4 plus c. So we have 7 is equals to 4 plus c. So c is equals to 3. So now substitute this value in the general solution. So the equation of the curve is y equals 2 4 over 5 minus 2x and plus 3. This is the required equation whose first derivative is this and passes to the point 2, 7. Question number 3. In this question we are given with the position vector of A and B, and we have to find out the unit vector in the direction of vector OC, and we are given with this equation AB vector is equals to BC vector. So let's use this information. AB vector is equals to BC vector. Now let's convert these vectors in terms of position vectors. So AB vector can be written as OB minus OA. Similarly, BC vector can be written as OC minus OB. We have vector B, A. Let's simplify. Take all the vectors to the left hand side but not C, because we have to find OC vector. Now let's substitute the values, making OC as a subject, and substitute the values of OB and OA in terms of position vectors. 4, minus 4 and 2. We can solve in IJK form as well, but it is convenient to solve in position vectors. 2, minus 5 and minus 2. After simplification we have 8 minus 2, it is 6, minus 8 plus 5, that would be minus 3, and then 4 plus 4. 4 plus 2 is 6. So this is our required OC vector. Now we have to find the vector which is parallel to OC and has a length of 1, that is unit vector. In order to find out that vector, we have to find out the length of OC, that is its magnitude. The formula is x square plus y square plus z square and then the square root of whole thing. This is the magnitude of OC. Simplify this. 36 plus 36 plus 9, that would be 81, and the square root will be 9. So we have the OC vector and its length as well. Now we have to find out the vector which is in the direction of OC and has a length of 1. What is the formula? The formula is unit vector is equals to vector, that is vector is OC, divided by its magnitude, OC's magnitude. So it means OC, usually we represent OC, the vector, and this cap sign represents the unit vector. We are going to divide the OC vector by its magnitude, which is 9. OC vector is 6, minus 3 and 6. After simplification, we have 2 over 3 minus 1 over 3 and 2 over 3. We can write this information in IJK form as well. We can write it like 2 over 3, first one is x, so it is I, minus 1 over 3 j plus 2 over 3 k. Now this is our required unit vector which is in the direction of OC and has a length of 1 unit. Question number 4. We have a binomial theorem and we have to find out the term independent of x. In order to do that, let's write on the basic formula. The formula is a plus b raised to the power n CR a b n minus r and r, and the values of r would be from 0, 1 till 6. For this particular question, it would be 6 CR x raised to the power 6 minus r minus 2 over x raised to the power r. And we have t means term. It is usually represented by r plus 1. If we substitute r0, that would be first term, and so on. Now if we have to find out the value of x raised to the power 0. So first of all, let's find out x bar in terms of r. From the first x we have x raised to the power 6 minus r. From the second x we have x raised to the power minus r. After simplification we have x raised to the power 2 minus r. This is our x power in terms of r. Now in this question we have to find out term independent of x, means x raised to the power 0. This is our requirement. Now let's equate these two values. X raised to the power 6 minus 2r equals to x raised to the power 0. So 6 minus 2r, x raised to the power 0, 6 is equals to 0. So we have r equals to 3. So if we substitute r equals to 3 over here, we will get our required term. R equals to 3 means that would be our fourth term, and 6c3 x raised to the power 3 minus 2 over x raised to the power 3 as well. Now use your calculators. Let's see what is the value of 6c3. It is 20. X raised to the power 3 minus 8 over x raised to the power 3. After simplification, x will be cancelled out and we are left with 160. This is our fourth term, and this term is independent of x. This is our required term. Question number 4. Now we have to find the product of these two factors such that the output is term independent of x. That is, we are interested in the terms in which x is power 0. So it means we are going to multiply 2 with some constant term which we have calculated in the previous part, and this x raised to the power minus 2 should be multiplied with such a term so that x raised to the power 0. So this x raised to the power minus 2 should be multiplied with x raised to the power 2 from the binomial theorem. And we know from the previous working that the formula for this expression is 6x minus 2 over x, it's r, and 6 minus r, and x power in terms of r is 6 minus 2r. This is the working we have done in the previous part. And now we have to find out the value of r for which we have x raised to the power 2. Now let's solve this. Base is same, powers are equal, so 2r equals to 4, r equals to 2. So this means if we put r2, then we will have the term in which x is square. 4 minus 2 over x square, and this is the third term also. 62 is 15 times x4, then we have 4 over x square, and the final answer is 15 4 is 60 x square. So we have our required terms. Now let's write down the question. Our first factor is 2 plus 3 over x square, and from the binomial theorem we have extracted only two terms which will give us x raised to the power 0 as a product. First term is 60x squared and the other one is minus 160. Now we multiply 2 with minus 160 so that we have a term independent of x, and 3 over x squared with 60x squared. Now let's simplify. 320 plus 180. So the final answer is minus 140. So this is a term independent of x from the product of these two factors. Question number 5. In the diagram, triangle ABC is right angle at point C and M is the midpoint of BC. It is given that angle ABC is pi over 3 in radians and angle BAM is theta radians, denoting the length of BM and MC by x. Find the length AM in terms of x as well. Now if you look at the big triangle ABC, it's a right angle triangle. So by using trigonometric ratios we can find the length AC. Let's apply tan pi over 3 is equals to perpendicular, opposite over adjacent. Now simplify this. So AC will be equals to 2x times tan pi over 3. Tan pi over 3 is square root 3. So it is square root of 3. This is our AC length. Now we have to find out AM length. Now consider triangle, right angle triangle AMC. AM is hypotenuse. So AM square is equals to AC square. This means AC square, that would be 4 3s are 12x square plus MC square, which is x square. Add these two, we have 13x square. This is AM square. Now we have to find AM length, taking the square root of both sides. We have square root of 13 and x outside the under root or square root. It's better to write square root first so that we don't have any ambiguity. So this is your length AM in terms of x. Question number 5, same question, second part. Now we have to show that this angle theta, which is in triangle BMA, is pi over 6 minus tan inverse 1 over 2 square root 3. Now first of all, let's observe the triangle. In this right angle triangle, the big right angle triangle, this is pi over 3, this is 90 means pi over 2. Now if we subtract it from pi, which is 180, so this total angle is pi over 6. Okay, what else we have? We have already calculated the length AM and AC. What is the value of AC? It is 2 square root 3 and x. And what is the length of AM? It was under root 13x. Now let's find out this angle MAC. Once we have this angle, we will subtract it from pi over 6. Now let's focus on the small right angle triangle AMC, and we are going to calculate MAC. So tan MAC is equals to perpendicular, which is x, base, which is 2 under root 3 x. X cancel out and we have our angle MAC equals to tan inverse of 1 over 2 square root of 3. This is our angle MAC. This small angle, this much is. Now we have to find theta angle. So theta angle is BAC, which is pi over 6, minus MAC, which we have just calculated. Now angle BAC is pi over 6 and MAC is tan inverse 1 over 2 square root 3. So we have proved that. Question number 6. In this question, we are given with the diagram. The diagram shows a circle with radius r, center O. The line PT is a tangent to the circle at P and angle POT is alpha radians. The line OT meets a circle at Q. Express the perimeter of the shaded region PQT in terms of r and alpha. Now first of all, let's see what is the perimeter made up of. It is this length PT, this arc PQ, and another length QT. So it means we have to find PT length, OT length, then we subtract R, we will get QT, and this arc length PQ. Very simple. So let's start with the length PT. If you focus on this right angle triangle, we can apply trigonometric ratios. So tan alpha perpendicular is PT and the base is R. So the PT length is R tan alpha. So it means we have our first requirement, PT. Let's find out the other length, OT. Now this OT is the hypotenuse and we have the angle, we have the side, so we will apply cos. Cos alpha equals to base, which is R, and hypotenuse, which is OT. So OT would be R over cos alpha. We have OT and we know that OQ is also R, so we can find our required length QT. That would be total length, that is OT, R over cos alpha, minus OQ, which is radius. So we have our two required lengths with us. Now we have to find the arc length PQ. We know the formula, S is equals to R theta. We are going to apply it for this sector. We have the length, we have the angle, we know the formula as well. The formula is S is equals to R theta. S is the arc PQ. Arc PQ would be angle alpha, radius R. So it would be R alpha. This is P. So we have all the three required lengths, all the three boundary informations to write down the perimeter. So therefore, our perimeter is PT, which is R tan alpha, plus QT, which is R cos alpha, minus R, plus PQ, which is R alpha. So this is our required perimeter. We can rearrange it, we can take R common, or we can leave it as it is. It is acceptable in all ways. If you want to take R common to make it a little neater, you can do so. Tan alpha plus 1 over cos alpha minus 1 plus alpha. This is also acceptable. Both are acceptable in fact. This is the required perimeter of the shaded region. Question number 6, second part. Same question, this time the value of alpha is given. It is pi over 3 and the radius is 10. Now we have to find area of the shaded region. Shaded region means area of triangle minus area of sector. Let's find this information one by one. First, let's find area of sector. The formula A half r square theta. Half r square means 10 square theta, which is pi over 3. 100 over 250, so it is 50 pi over 3. This is area of sector. Then area of triangle. Now for area of the triangle, we have to find the length PT first. So let's use trigonometric ratios. Tan pi over 3, PT is perpendicular, base is 10. So PT is 10 times of tan pi over 3, which is square root of 3. So therefore, area of triangle, half into base into height. Base is PT, which is 10 square root of 3, and height is 10. So area of triangle is 50 square root of 3. Now the required area would be required area of triangle minus area of sector. Area of triangle is 50 square root of 3 minus area of sector 50 pi over 3. We can take 50 common as well. So after taking the common, we have 50 square root of 3 minus pi over 3. That would be our final answer if it is required to write your answer in exact form. But in this question, it is required to write your answer in two significant figures. So after simplification with the help of calculator, we have 34.24266. Now round this information to 2SF, two significant figures. We have 34 centimeters square. So this is your required shaded region. Question number 7, trigonometry. We have to prove this identity. Let's choose the bigger side, which is left hand side. In this case, left hand side, we will simplify and equate it to right hand side. Let's take the LCM of left hand side. LCM would be 1 minus cos theta, 1 plus cos theta, and the numerator would become 1 plus cos theta into 1 plus cos theta whole square, 1 minus cos theta into 1 minus cos theta again whole square. Now let's expand these. It is a square plus 2ab plus b square, then minus a square, minus minus, then plus because of the negative sign outside the brackets, then plus, then minus cos square, whole thing divided by 1 minus cos theta. This means 1 minus cos square theta. Now things which are being cancelled out are cos square, 1 with 1. So we have 4 cos theta over sine square theta. We can write it as 4 cos theta over sine theta over sine theta. Now we have to prove tan theta. So we can divide numerator and denominator by cos, so that this becomes 1. So this becomes 4 over sine theta. Sine over cos, that becomes tan theta. This is our right hand side. We have proved that identity. for your understanding, we can do one more step if you are a little confused. In the numerator we have 4 cos theta. In the denominator we have sine theta, sine theta. What we have done over here, we have divided the denominator as well as the numerator by cos. So this is cancelled out and this thing becomes tan theta. So we have 4 divided by sine theta, tan theta. So that's why it becomes 4 over sine theta, tan theta. This is for your understanding. You can do it directly if you are fully confident. Question 7, second part. Now hence solve this equation for 0 to 360 degree. Hence means we have to use the previous working. We have just proved that 1 plus cos theta over 1 minus cos theta minus 1 minus cos theta over 1 plus cos theta, the thing which is inside the bracket, is equals to 4 over sine theta, tan theta. So now just replace that value on the left hand side. So we have sine theta 4 over sine theta, tan theta is equals to 3. Now sine theta cancelled out with sine theta, so we are left with 4 over tan theta is equals to 3. Let's do the cross multiplication. So we have tan theta is equals to 4 over 3. Now this is a simple trigonometric equation. You know how to solve the trigonometric equation. It has 3 basic steps. First one is identify the quadrant. Tan theta is positive, so it means it is in either first quadrant or it is in third quadrant. Let's find out its basic angle. Tan alpha 4 over 3. Its basic angle is 53.1. Now let's make a sketch. We're going to make a sketch. As we have mentioned earlier, the angle is either in first quadrant or in third quadrant. The basic angle is in 53.1, either in first or in the third quadrant. So what would be the value? In the third quadrant, it is 53.1. In the third quadrant, 180 plus 53.1, that would be 233.1. Question number 8. Coordinate geometry. 3 points have coordinates A, B, C. Find the value of the constant K for which C lies on the line which passes through A and B. It means point A, B, C are collinear points. It means the gradient of AB, BC and AC all are same. Now let's find out the gradients. So what would be the gradient of AB? Gradient of AB, y2 minus y1, 3 minus 7, x2 minus x1, 8 minus 0. That would be minus 4 over 8, minus 1 over 2. Now let's find gradient of BC. Again, the formula is the same, y2 minus y1 over x2 minus x1. Now as these two gradients are same, it means they are collinear. Now let's equate them. Minus 1 over 2 equals to k minus 3 over 3k minus 8. Cross multiply. So minus 3k plus 8 is equals to 2k minus 6. So we have 8 plus 6, 14. 3k plus 5, 3k plus 2 is 5k. So after solving this, we have k equals to 2.8. This is the value of K if C lies on the line A and B. It means if A, B and C are collinear, then the value of K is 2.8. Question number 8, second part. Now the condition is C lies on the perpendicular bisector of AB. Let's say this is line AB, and its perpendicular bisector means a line which is passing through the middle of AB and making 90-degree angle. This is perpendicular bisector of AB, and on this perpendicular bisector we have somewhere over here we have C. So it means that gradient of AB and the gradient of that perpendicular bisector, their product is -1. As this is a perpendicular bisector, it means this point, let's say this point is M. This is the midpoint of AB. It means first of all we have to find out the midpoint of AB. Midpoint of AB. The formula for the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. We are going to apply this formula on point A and B. So x1 plus x2 over 2 and y1 plus y2 over 2. So the midpoint is 4 and 5. Now we will find the gradient of CM. Let's say this point is M, CM and AB. First of all, let's find the gradient of CM. Gradient of CM. Y2 minus y1, 5 minus k over x2 minus x1, 4 minus 3k. And gradient of AB, which we have just calculated in the previous part, gradient of AB is -1 over 2. Now whenever two lines are perpendicular, the product of the gradients is -1. We know that property. So by using that property, the product of these two gradients is -1. Let's substitute the values of these two gradients. 5 minus k over 4 minus 3k. Let's say this is M1, the first gradient, and this is over M2. Now simplify this, multiply the numerators. So we have -5 plus k, and the denominators we have 8 minus 6k is equals to -1. Do the cross multiplication. We have -8 plus 6k. Take this 8 on the left hand side, -5 plus 8, 3, and that will become 5k. Simplify this, 3 over 5. So k is equal to 0.6. The value of k is 0.6 if C lies on the perpendicular bisector of AB. Question number 9. A water tank holds 2000 liters when full. A small hole in the base is gradually getting bigger, so that each day a greater amount of water is lost. On the first day after filling, 10 liters of water are lost, and this increases by 2 liters each day. How many liters will be lost on the 30th day after filling? First of all, we have to see what type of question this is. In this question, we are losing water. In the first day, we lost 10, then 12, then 14, then 16. It means we have a common difference. Whenever we have a common difference, this means this is an arithmetic progression. Here, first term is 10, common difference is 2. So let's derive the formula at the first place. We know the formula for the arithmetic progression, a plus n minus 1d. Let's substitute the values. So we have n minus 1 times 2. After simplification, we have 2n minus 2. So we have finally 2n plus 8. This is the formula for the arithmetic progression. Now in the A part, we have to find out how many liters of water is lost on the 30th day. It means N is 30. So replace N 30 in the general formula. So we have 2 times of 30. So it is 68. It means we lose 68 liters of water on the 30th day. On the first day, the loss was 10, second day 12. On the 30th day, the loss is 68 liters. Question number 9. Now for the same question, we have to find out after how many days the whole tank will be empty. It means we have to find out the total sum of 2000 liters when it will be consumed and when it will be lost. It means this time we have to find out the sum. We know the formula for the sum is N over 2 2A N minus 1 times D. We have to find out the value of N after which the whole water tank will be empty. It means we have to consume, we have to finish 2000 liters. N means this is what we have to find out. First term is still 10. The common difference is 2. Now let's simplify this and let's see what's happening. Cross multiply, we have 4000 N times of 20 plus 2N minus 2. So we have 4000, that is N times of 2N plus 18. Now multiply this, we have 2N square plus 18N minus 4000 equals 0. We can divide the whole equation by 2 for simplification purposes. N square 9N minus 2000 equal to 0. Now apply any formula, quadratic formula or computing square, whatever is suitable. After substituting the values in the quadratic formula or using the computing square, we have two answers. One is positive, the other one is negative. After solving this, we have 40.447 and 49.447. We know that N cannot be negative, so we will not consider that value. So N is 40.447. Now it means on the 40th day it was not empty. It is empty in the next day. It means the tank is empty in the 41st day. So that means 2000 liters will be lost on the 41st day. Question number 9, second part. Assume instead that 10 liters of water are lost on the first day and that amount of water lost increases by 10% on each succeeding day. Instead of 2 liters, now it is 10%. For what percentage of the original 2000 liters is left in the tank at the end of 30th day? Now this is a geometric progression. On the first day we have lost 10 liters. On the second day we will lose 10% more. This means on the second day we will lose 1.1 times 10. On the second day we will lose 11 liters. Again 10% more. So in the third day we will lose 12.1. We are increasing 10% on each day. It means then 13.31 and so on. Each day we are increasing 10% of the previous day. Now this is 10% of 10 being added, 10% of 11 being added, and 10% of 12.1 is being added. Now this is a geometric progression. Now what is the value of R over here? R means T2 second term divided by first term. It is 11 over 10. It is 1.1. So this is the value of R. This is also obvious from the statement, but we have just calculated to be on the safe side. The value of R is 1.1 and the value of A, which is first term, is the same, 10. Now we have to find out how much water is left after 30 days. It means we have to find the sum of liters which are being lost in the first 30 days. So what is the formula for the R? If R is greater than 1, then the sum for the formula of geometric series is A R raised to the power n minus 1 over R minus 1. We have to find out the sum of 30 days. So it means n is 30, A is 10, 1.1 raised to the power 30 minus 1 over 1.1 minus 1. Now use your calculators to find out this value. After solving this, we have 1644.94 liters. That much amount we have lost after 30 days. Now how much water is left? Now we are left with 2000, the original amount, minus the water which is being lost in these 30 days. Subtract these two values. So the total amount now we have inside the water tank is 355.05 liters. This much we have still inside the water tank. 0.9098. Okay, now what else we have to do? We have to find out the percentage of the original amount which is being left. So percentage of water left, percentage water left water is 355.0598 divided by the original value, which is 2000 multiplied by 100%. So the answer is 17.75299, that is 17.75 liters or 17.8 liters, 17.8%. Question number 10. The diagram shows the part of the curve and M is the minimum point. This is our diagram. The equation of the curve is given. M is the minimum point of the curve. In the first part, we have to find the derivative, first derivative, second derivative, and the integration of y square. So let me write down this equation. Y equals to 8x raised to the power minus 1 plus 2x. That would be easy for differentiation purpose. First derivative, dy over dx, that would be minus 8x minus 2 plus 2. We can write it minus 8 over x square plus 2. This is our first derivative, dy over dx. Now we have to differentiate it again to find out the second derivative. For that, I'm using this expression, d square y over dx square, that is the second derivative, minus 2 times minus 8, that would be 16. Reduce the power by 1, minus 3. Derivative of constant is 0. So we have 16 over x cube. This is our required 16 over x cube. 16 over x cube. 16 over x cube. This is our required second derivative. We have done the first derivative and second derivative. Now we have to integrate this y squared. This means square of this expression, 8 over x, 2 over x square dx. This is a plus b whole square. Now let's open it. 64 over x square 2ab. That would become 32. 8 for the 32. X cancelled out. Plus 4x square. We have just opened a plus b whole square. So far we have not done the integration. Now let's do the integration. Let's do the integration. Before integration, let's take everything in the numerator. It would be x raised to the power minus 2 plus 32 plus 4x square. Now let's do the integration. That would be 64 x raised to the power minus 1 over minus 1 plus 32x plus 4x cube over 3 plus 3. After simplification we have minus 64 over x plus 32x plus 4x cube over 3 plus c. Find the coordinates of M and determine the nature of the other point on the curve when x is less than 0. Now for the stationary point, we always put first derivative equal to 0. Now substituting x is equal, first derivative equal to 0. Now let's substitute the values. We have already calculated the first derivative. So minus 8 over x square is equals to minus 2. This is cancelled out. So x square is equals to 8. X is equals to plus minus 2, 2 or minus 2. Now for m, we know that m is in the first quadrant, x is positive. Now for m, we will put x is equals to 2 in the curve. So y is equals to 8 over 2 plus 2 to the 4. 4 plus 4 is 8. That means the coordinates of m are 2 and 8. The first portion of the question has been done. And further, it is required find the coordinates of the point when x is less than 0. That is when x is negative. The value of x negative is minus 2. So now let's put that value in the curve to find its corresponding y. 2 times of minus 2 minus 4 minus 4, this is minus 8. So the other point is minus 2 minus 8, which is not m. And we have to find its nature. To find nature, we substitute this value in the second derivative. In the second derivative, we are going to replace the x coordinate. We know what is the second derivative? It is 16. The second derivative we have just calculated is 16 over x cube. Now let's substitute the value in the second derivative, that is minus 2 minus 2 minus 2 raised to the power 3 minus 8. 16 over minus 8 is minus 2, which is a negative value. Whenever second derivative is negative after substituting the x coordinate of the stationary point, this means that point is maximum point. Therefore minus 2 minus 8 is maximum point. Is maximum point because second derivative is negative. Question 10, third part. Find the volume obtained when the region bounded by the curve, the x-axis, and the lines x is equals to 1 and x is equals to 2 is rotated 360 degree about the x-axis. We know the formula. Whenever a curve is rotated about the x-axis, the formula is y square dx. And this x is equals to 1 and x is equal to 2. These are the limits. This is a generalized formula. And in the first part, we have already calculated y square dx. Let's see, what is that answer? Y square dx was minus 64 over x plus 32x plus 4x cube over 3, and the limits are 1 to 2. Now we are going to replace these limits and find our required volume. First we are going to replace the upper limit, then the lower limit. Upper limit is 2, so 64 over 2, 32 into 2 is 64 plus 2 cube is 8, so it is 32 over 3. Then we replace 1, so it is minus 64 plus 32 plus 4 over 3. Now simplify this using your calculator. We have 128 over 3 minus, we have negative 92 over 3, and minus becomes plus. Now add these, 92 plus 128, we have 220 over 3. So it means the volume is 220 over 3 pi. Or we can write in the form of fraction, that is 73 whole 1 over 3 pi. Or we can convert this into decimals form, that would be 230.38, so we can write to 3SF 230 units cube. This is our required volume. Question number 11. We are given with the function 6x minus x square minus x. The domain is all real numbers. We have to find a set of values for which the function 6x minus x square minus 5 is less than equals to 3. Now this is a quadratic inequality. You know the steps. First of all, we take everything to left hand side so that the right hand side is 0. Then we have to factorize. It's better to have the coefficient of x square positive. So multiply the whole quadratic inequality with a negative number, with minus 1. We have changed the sign of the coefficient of x square, positive. Now let's do the middle term break. You know how to do it. X minus 4, x minus 2 greater than equal to 0. Now you have two options, in fact 3. You can draw parabola, you can draw a number line, or you can plug in the values. The choice is yours. I'm using parabola. Here coefficient of x square is positive, so it is going to be a U-shaped curve, and the x-intercepts are 2 and 4, so 2 and 4. We have to find out the positive region. It means the whole curve should be positive. It means the whole curve is above the x-axis. So this is a portion for which the curve is above the x-axis. So it means our required answer, or the required quadratic inequality, is x less than equals to 2 or x greater than equals to 4. For these values of x, the function is lesser than equals to 3. Question number 11, second part. Given that this line and the curve, they are tangent, whether the line or the curve are meeting, intersecting, 2 point, 1 point, or no point, the first step is the same. that we are going to solve them simultaneously. We have the line y is equals to mx. The curve is y is equals to 6x minus x squared minus 5. Let's eliminate y. So we have mx plus c is equals to 6x minus x squared minus 5. Now let's take everything to left hand side. So we have x squared plus mx minus 6x plus c plus 5 equal to 0. We have only one term of x squared, write x squared, two terms of x, so let's take x common. We have m minus 6. Then we have constant terms c and 5. Now after having done this, now we see the condition. It is given that the line is intersecting the curve at one point. It's written tangent. Whenever it is tangent, it means one root. So using the definition of the root, nature of roots, discriminant b square minus 4ac will be equals to 0. Now let's replace the values. B is m minus 6, a is 1, c is c plus 5. Now let's solve this. A minus b whole square, so it is m square minus 12m plus 36 minus 4c minus 20 equal to 0. Now solve this. We have m square minus 12m plus 16 is equals to 4c. Now let's switch the sides. 4c equals to m square minus 12m plus 16. This is what we have to prove. We have to prove that 4c is equals to m square minus 12m plus 16. Question 7, third part. We are given with the function and we have to transform this into a completed square form. We know the process. We write on the given function in descending powers of x. X squared plus 6x minus 5. And then we make coefficient of x squared 1. It is not 1 already. So take minus 1 common. So now we have x squared coefficient positive inside the brackets. Now what is the third step? Third step is write down the first two terms as it is and then see what is the coefficient of x. It is 6. Make half of it. That would be 3. So add 3 square and subtract 3 square. Now as a result, the first three terms become a perfect square. A minus b whole square. So it is x minus 3 whole square minus 9 and minus 5 outside the brackets. Open the brackets, we have x minus 3 whole square plus 9 minus 5. So 9 minus 5 is 4. That is 4 minus x minus 3 whole square, and this is our required completed square form. Fourth part, state the smallest value of k for which the g has inverse. What is g? G is in this form. We have 4 minus x minus 3 whole square. As we know already that here the line of symmetry is x is equal to 3. It means the curve is going to be like this and the line of symmetry is x is equal to 3, and in the question it is given that the domain is greater than equals to k. It means we are supposed to move right from some point so that it is a one-to-one function. That is, in simple words, we want to say that the values of y should be unique, should be not repeating. So it means we should move on from the line of symmetry further. it means our domain should be x greater than equals to 3. So therefore the value of k on will be equals to 3. This is the smallest value of x, which will make g one-to-one function, and in short, in that way it would give us an inverse function. Question number 11, 5 part, we have the function g of x equals to 4 minus x minus 3 whole square. We have to find its inverse. We have already defined that it is one-to-one function. We can find its inverse. So let's use the old method. The method is, let's suppose y is equals to g of x. We are going to replace y with the function y minus x minus 3 whole square. Then we interchange x and y. Wherever x we will write y, wherever y we will write x. Now after this we will make y again subject to the formula. Now our target is to make y as subject of the formula. Take the square root of both sides, y minus 3, 4 minus x. Now outside this bracket we will have either plus or minus. Now if the domain of the function is right to the line of symmetry, we will put plus over here. If it is left to the line of symmetry, then we will put negative over here. So far it is greater, so we put plus. So y is equals to 3 plus square root 4 minus x. Now y is the subject of the formula, so therefore g inverse x is equals to 3 plus 4 minus x. This is our required inverse function. This is your channel, Math Mentor 75. I'm your teacher, Asif Salim. In this channel, we are studying mathematics of O and A levels, additional mathematics of O levels, and further mathematics of A levels. We'll be dealing here all the topics, in fact, the important topics at the first place, and then we will solve the past papers of all these 4 subjects. So stay tuned and keep in touch. Also promote this channel so that others can benefit from it.